Thank you for welcoming. So I think it is time to start. My name is Yelena, and I will introduce my colleague and co-founder, Emeli. So Emeli is a co-founder and CTO at EvidentlyAI. Evidently is a startup that is focused on building machine learning model monitoring analytics tools. Prior to that, she co-founded a startup focused on industrial manufacturing applications of machine learning. And she also served as the chief data scientist of Yandex Data Factory. So all in all, she implemented more than 50 different applications of machine learning in different industries. She also is co-author and a creator of a curriculum on Coursera focused on machine learning and data analytics, which has over 100,000 students. It is one of the most popular courses in machine learning in Russian language. And she also created Data Mining in Action, the largest open data science course in Russia. And today, Emeli will be talking about machine learning model monitoring and failures that your model can experience in production. So Emeli, I leave it to you now.
Thank you so much for such a great introduction. Hi there, I'm happy to welcome you in this session. And today we are going to talk about what can happen with machine learning models once you put them in production and how to prepare for it. My talk will be based on my experience working on machine learning application for different industries from banking to telecommunication and manufacturing, so it will be more practical than academic. And it's well known that to build a complex machine learning model is a hard task. We need to run a bunch of experiments, do a lot of feature engineering, data preprocessing. Then we need to move our model in production, and this is its own challenge. But sadly, even if we move our model into production, our work doesn't stop there because, well, there is a lot of things that can happen with model which is already in use, and these failures cost even more because model already in production, it generates some business value, and every failure costs something. So what can we do with this? We can try to overcome all these issues by setting the proper monitoring. In most cases, when something goes wrong with our model, it's something wrong with the data. For example, our data pipelines can break, or you can lose access to the file and pipeline will break because you don't know the correct location. Or data schema can change, and this is a really big issue because imagine you have a machine learning model that uses data from some business system like CRM, and CRM user once decided to update the system, for example, rename a couple of columns or move it around, and if your model uses this data as an input, it will break. Or, for example, data can just lost. If you have some physical sensor, it can be breaking, or logging can be implemented incorrectly or something like this. And if you have a bunch of models depending on each other, if something goes wrong with your first model and this first model starts generate the wrong output, then all other models which uses the output from first model as a feature, for example, will suffer from it. Even if everything is okay with the input data, the model still can underperform. For example, here is the situation which is called data drift, where the input data changes. For example, imagine we have some online service and we build a model to predict future users' behavior. If during training we had specific users, and once we start seeing users coming, for example, from Facebook instead of paid search more often, then our model can break because the proportion of users changes, and now we have a lot of users which our model didn't see during the training phase. So this is basically a new segment of object, and our model needs to learn how to work with them. Another issue is concept drift. This is a situation where input data can stay the same, but the world can change a lot. And the recent pandemic is a perfect example of such a thing. Almost overnight, a lot of patterns has changed. People decided to stay home, planes do not fly, so our models were confused by all these new patterns. In this case, concept drift can happen in different ways. For example, it can be some gradual concept drift where small changes accumulate over time, and in this situation we need to retrain our model from time to time. And this speed of degradation can be even estimated during the training period. And the sudden concept drift, this is something that's really hard to miss, as I said before, like recent pandemic. And in these cases, we really need to rebuild our model from scratch very often, because such changes isn't something that you can just somehow prepare for or just retrain our model. So there are a lot of different issues that can happen, and the only way to account for it is to know about it beforehand. So it's really embarrassing when, for example, we know about some problems from our users, or if we do not notice that our model didn't work for weeks. But sadly, such things are still happening. So to be prepared to it, we need either set up monitoring for our machine learning models, either analyze logs regularly. One can say, okay, but we have production services for ages, why cannot we just reuse the existing monitoring schema for our machine learning services? Well, there is some truth to it. We need to monitor service health, because machine learning-based service is a service, right? So we need to measure uptime, memory, latency, and so on. But we also had an extra layer of data, so we need to monitor data quality, and we need to make sure that our model is still relevant, because we have things like concept drift and data drift. The FICO company recently performed research. They asked the enterprise company if they monitor their model, and it turns out that a lot of companies actually do not do this. I wonder if you do. So this shows that the monitoring for machine learning model is really something we need to think about. So before we go to the details about what to monitor, I want to discuss how to monitor, because, well, if a machine learning-based service is not your first production service, then probably you already have some infrastructure like Prometheus for storing logs, or Grafana for dashboards and alerts. And the idea is just reuse the existing infrastructure for your machine learning models. You might only need to start logging more and create some specific alerts for data integrity, for example, and model performance. So you need to create specific metrics and alerts, but you can reuse the existing infrastructure. And the tools, the BI tools like Tableau, Looker, or maybe a custom tool developed with help of Matplotlib or Plotly or other library you like, also can be used for monitoring, but only if you have models working in batch mode. In this case, you can use such tools. They are flexible, easy to use, but of course they do not cover the real-time scenario, but they can be an excellent start for monitoring. So, okay, now let's discuss how to start. And here I suggest to be pragmatic and move step by step, starting from something basic and continue with something more advanced. And before we do that, I just want to say that we can actually calculate really a lot of different metrics, but the question is, do we really need them all? And do we really have resources to implement them all? So I suggest us take into account three main factors. First, use case importance. This is basically the criticality of your problem statement. Second is complexity. Batch is different from real time, right? And the more pipelines you have, the more complicated monitoring you probably need. And of course, team resources. And taking into account all three factors, decide how much thing you need to monitor. And let's choose a specific example. This is the regression problem where we need to forecast demand for public rental service. We have data about weather conditions, seasonality, weekends, holidays, and so on. And based on this data, we need to predict the demand. So let's start from something basic. And as I said before, machine learning-based service is a service. So we need to monitor service health. Why? Because first of all, we need to know if our service actually works or not. And here, there is only one thing I suggest to add together with your basic service health monitoring is model calls, because sometimes the software is working. I mean, you get your responses, but for example, you may get your responses from some fallback system while your machine learning doesn't work. So it's always good to measure explicitly how much model calls do you have. When we set up our service health monitoring, it's time to make sure that our model works well. So we need to basically focus on two things: how well model performs, and did anything break and require our attention. So here, model performance monitoring can help. And of course, the exact model performance monitoring always depends on the use case, right? So, for example, we can have some use case where we get our feedback really fast. For example, we implemented recommender system. We recommend something to our users, like films or products, and user immediately react. So they either click or buy something or skip. In this case, we immediately have feedback, so we can calculate any quality metric you like, for example, error rate or accuracy score or whatever, and a lot of analysts are quite comfortable with this. But in many cases, we do not have this feedback that soon. For example, we can work on demand forecast problem with a large horizon, like months or couple of months. And in these cases, it's sometimes quite complicated to figure out model quality. And here I suggest not to wait until we get this feedback, but analyze something we already have. And this is the model output. For most cases, we can generate pretty interesting expectation for our model's output distribution. For example, we can assume that our model output distribution should be non-negative. For example, for demand forecasting, or it could be within the expected ranges, right? If we forecast the user's age, or it can have some specific distribution, for example, normal with fixed mean. And the idea is to check all these expectations because it can be checked without any feedback. So such rules can help us to understand and indirectly whether everything is okay with our model. And it's even better if you have some model output distribution from the training phase, because if you have, you can compare your production output distribution with your training output distribution. And if they are similar, then probably everything is okay. If they are different, it does not necessarily mean that something goes wrong, but it can be a signal. So it's better when you understand why they are different as they are. Later, if you have some feedback, then it's easy because you can directly calculate some quality metric. And here I just want to say that the choice of specific metric is very important. You better choose the metric that tells you very straightforward what is happening. Here, I mean, for example, it's not always a good idea to use accuracy score for imbalanced binary classification, because if something goes wrong with your minor class, you can just miss it because the accuracy score will be still high, right? So the choice of specific metric is pretty important. And I also suggest from time to time analyze zero distribution, because it will help you to understand what is happening with your model from broader perspective, right? So you can, for example, figure out whether your model zero is still symmetric to zero, or your model started underestimate or overestimate your target function. So this is pretty interesting thing. And the last thing about model performance is some business metric, because I personally believe that it's very good practice and it's very important to keep all teams informed about what's happening with your service. So I always suggest to sit together with your business team and come up with some ideas how model quality is connected with some business KPI, and calculate some metric that will give a lot of information about model's quality to your business team. Like here, we assume that it's better to keep the error under 100 of bikes, right? And this is why we implemented metric share of errors. And something like this will be really nice to keep all teams informed. So I suggest to come up with something like this and publish it to everybody. And once we implemented model performance monitoring, we know if our model works correctly or if something goes wrong. And if something breaks, we need to know where exactly it breaks and where to dig deeper. And here, data quality and data integrity can help, because in most cases, if something wrong with model, it's because the data is wrong. So I suggest to start with data integrity. And here we have the metrics that shows us how much missing data do we have. And there is many ways to implement such monitoring. You can aggregate information about missing data for all features, or you can calculate it feature-wise. But yes, for larger data sets, it can be hard to visualize and analyze these statistics feature-wise. But in this case, I suggest just select the key drivers, the most powerful features, and analyze them only. And if you have more resources, check for type mismatch and range violations for your features. And with range compliance, it's not that straightforward, because sometimes our feature can be within the expected range, but already be broken. For example, imagine you have a physical temperature sensor, which should be within the range from 0 Celsius to 100 Celsius. And our temperature sensor breaks, and starting always show 0 Celsius. So this is still within the expected ranges, but the feature is already broken. And if this is a strong feature for our model can really suffer from it. And this is something we need to catch fast. So to catch such things, we need to analyze individual feature distribution, multivariate distribution of subset of features, and this is pretty complex analysis. And I suggest us to be pragmatic here also and calculate something more simple like feature correlations. And of course, you should say, come on, the feature correlation is just a linear dependency between the features, so it will not tell us everything about our features. And yes, I agree, but if our features changes a lot, then probably some linear dependencies will change also. So my idea is here to calculate feature correlations on training set, then calculate feature correlations on production, and just compare them. And if you will see some difference, try to figure out what has happened. For example, here during training, we had positive correlation between months and temperature, and during the production, we start seeing the negative correlation between months and temperature. And here the answer is the training period, because we trained our model during spring and summer, so with increasing number of months, our temperature increased. But we started apply our model only in autumn, so with the increasing number of months, the temperature starts decreasing, right? So, and if this feature is important, it's really good to catch it faster. So we know that even if our data is correct, model can still suffer from data drift and concept drift, and both are pretty complicated to catch. And here again, I have some pragmatic approach. I suggest to compare distributions for key drivers and compare distributions from production and training. Why it's important? Because, well, first of all, we can do it pretty much easily because we have a lot of statistical tests to use here. For example, Kolmogorov-Smirnov test, Anderson test, or chi-square test if you have categorical features. And you can just calculate such tests from time to time and see whether our data started differ from training phase so much. Or you can actually use some visual analysis like you can see in the green plot. Here we just plotted the temperature over time, and you can see that from the beginning of November, our temperature starts decreasing. So it basically means that it's no longer within the expected range and something has changed, right? So this is also a nice plot to analyze what is happening. And this visual analysis can be actually quantified because, for example, we can check whether there is any linear trend in our feature, and if there is, then probably we could suspect that there is data drift or something like this. So I suggest to do it for your key drivers to make sure that the strongest factor are not drifting. So, okay, finally, I want to say that there are a lot of different things that you can measure depending on the criticality of your case. And we just discussed very minimalistic monitoring, but if you have a very critical case, for example, in finance or medicine, you can analyze performance by segment. I mean, measure performance not only for all data, but for specific segment, or even try to identify some low performance segment to work with them more deep. Or if you work, for example, in school grading or social services, it's important to make sure that there is no bias in your model and there is no issues with fairness. If you work with some credit scoring system, it's good to be able to figure out, to detect outliers and sometimes send them to manual review because it can increase the overall quality of your service, right? And the explainability layer is something very important to end users because it will help them to generate trust to the system and work with the system with more pleasure. To sum up, I just wanted to say that we discussed a lot of different metrics and parts of monitoring that we can use for different in different situations. The more critical your problem statement is, the more monitoring you need. And I only want to warn you about the danger zone when you have really high criticality problem. For example, the model that needs to take some important decisions in business, in finance, in healthcare, and if in this case you do not have enough resources to monitoring, I suggest you to really stop and think here, because the cost of error can be really very, very high. So this is pretty much it. That's all I wanted to share with you today. So I want to thank you for your attention, and if you have any comments and questions, I will be happy to chat, or you can drop us a line via this email. Thank you.
So we got the first question. Thank you everyone for posting it. So from Mark Donaldson. So let me read it aloud. Do you see an important need for organizations to create teams that have the role to specialize in model creation, performance, and monitoring on a consistent basis?
Oh, thank you. This is a good question. I believe it depends on the size of the organization by itself and on the number of models you have, because if you have really a lot of models differ from marketing to some core business and maybe other parts of company, it really makes sense because you can reuse the existing monitoring tools, monitoring schema, and some alerts, and you can really benefit a lot from having this specific team. But if, for example, you are a small company or even startup and you have like a couple of models in production, I believe it will be more spending than benefits. So I suggest to do it only for a bigger organization.
So one more question. Any practical suggestions for monitoring NLP services?
Oh, this is this is a really good question, because for NLP it's at least in my opinion quite harder. But yeah, I think it's highly dependent on this scenario, right? And in this case, I would go to some how to say keep some quality metric for your end service, right? I mean, some business metrics where you used your NLP machine learning model, and this will be like a direct signal that if something went wrong with your system at all, then maybe something wrong with your machine learning model. And some monitoring for data drift. I mean, whether your text data is still the same on your, or you have new text clusters or something like this. So yeah, I would go into this direction. The business metric for your system at all, like how many users you have, how many, for example, messages you have in help desk and other thing, and the data drift for text.
Yeah. Great. One more question. You mentioned feature correlation in production. How about new labels in production that were not seen in training?
Yes, that's also very important, and I believe it should be included into data drift calculation, but this depends on how exactly you pre-process your data during the feature engineering, because, well, there are a lot of tricks you could use. For example, you could have, if this is a categorical feature, right, and label is something that relates to categorical features, I believe. So in this case, you can have for each feature a specific label like new, and in this case, your model will not like break directly, but yes, this will influence. And if you pre-process your data like this, you will see that the share of this new cluster will increase, right? So I think it should be integrated into your feature, into your data drift analysis.
Okay. Are there any more questions out there? Let me quickly go through. Oh, I missed the one. How would you compare EvidentlyAI to other machine learning monitoring solutions out there?
Oh, here I believe, Elena, you could be a better person to answer, because as Elena said at the very beginning, he is, or she is, or I don't believe, did you actually say it or not, the CEO of our company? So can you please help with this question?
I'll give a quick answer. We will be open source. So unlike other closed source solutions, we're actually building open ecosystem, and we want everyone to benefit, even maybe if you have only a couple models in production and you don't have yet the chances to send all the data to some SaaS system. You want to just have the best practices from the ground up. So we want to enable this. So open source is a great differentiator. So one more question. Do you see a growing need and companies responding to this need to have AI and machine learning explainability, especially with pending worldwide legislation underway to let us know what the black box is doing? So explainability, do we need to do this?
Yeah, this is a hot factor and hot topic. Yes, I believe it also, I know it's a bit it's a bit complicated to do it because we have really different algorithms. Sometimes we use like a combination of different algorithms, right? And it's hard to explain each individual prediction, but this is interesting topic, and I believe it's needed, right? But the the level of digitalization can be really different. So I think depending on your problem statement, this level should be different. So for less critical tasks, you can have some general explanation, maybe some important factors, and that's it. But for very critical tasks, I believe the very strong and detailed explanation is needed, because like for healthcare or some social services, I believe it's better, especially when you take some important decisions, it's always good to understand how exactly model decide to do this. But for like less important cases, maybe just knowing about the strongest factor is more or less enough to trust to the model.
And simple models can rule the world. You don't necessarily need to create real black boxes.
You will be surprised how many linear models really work very well in specific cases. So, and for linear models, it's pretty much obvious how to get explanations. You just look at weights, right? So, yeah, sometimes it's not that hard, but for some boostings or neural networks, yeah, this is a hard task.
Okay, so if there are any more questions, please feel free to shoot, or else I left some links where you can connect with Emeli later on Twitter or LinkedIn. And you can follow. Soon we'll be releasing some first open source tools that you'll be able to try.
Yeah, thank you guys so much. Thank you for brilliant questions. I really enjoyed, and I will be happy to chat if you have some more questions later.